Hello everyone, welcome to In 5 Minutes. In this video clip, we will discuss the various types of sampling. We have already discussed in detail the sampling theorem for low pass signals and band pass signals. When we discussed sampling theorem for low pass signal, we considered the ideal sampling and we derived one very important condition that Fs has to be greater than equal to 2Fm. In ideal sampling, the sampling signal is train of impulses. In practice, we cannot generate an impulse signal because impulse signal mathematically has infinite magnitude and it exists at single time instant. Now such a signal cannot be generated practically. So practically we replace all the impulses with rectangular pulses. So as you can see in this case, when we are discussing the practical sampling in this diagram, you can see that the first waveform is nothing but my modulating signal which is to be sampled, and the second signal is the train of rectangular pulses. This time every rectangular pulse will try to replace the impulse of the train of impulses. In that attempt, you can see the rectangular pulse has some non-zero finite width which is not going to be equal to 0, because in case of an impulse its width is 0. So here we have taken the width of the rectangular pulses. So if you have taken width of the rectangular pulses to be a variable tau is the width. Ideally tau should be equal to 0. In practical case, we will make sure that tau is as small as possible so that the width of the rectangular pulse approaches to the width of the impulse. The next important thing is the finite magnitude of the impulse rectangular pulse. It is equal to A. Ideally an impulse will have infinite amplitude. Again, we cannot generate something which is of infinite value, so all the rectangular pulses have some finite amplitude. Here we are taking that value as A. The gap between the two rectangular pulses is Ts, which is the sampling time period. There are two types of practical sampling. So before we discuss them, I repeat, what we are discussing right now is practical sampling processes. There are two types. The first one is natural sampling. So we will discuss natural sampling first and then go to the second type of practical sampling. So what happens in natural sampling? In natural sampling, we take the modulating signal, you can see continuous time signal, and the sampling signal is the train of rectangular pulses this time. Each rectangular pulse will have the width of tau, and the Ts is the gap between the two pulses. Now to obtain the sampled signal, we will adjust the amplitude of each and every rectangular pulse as per the amplitude of the modulating signal. Or in simple words, we will record the magnitude of the modulating signal whenever the rectangular pulse in sampling signal occurs. So you can see when the first rectangular pulse occurs, the magnitude of the modulating signal is recorded by adjusting the height or the magnitude of the rectangular pulse. So you can see the output rectangular pulse is something which has magnitude exactly similar to the modulating signal. When the second rectangular pulse occurs, its magnitude will also be adjusted as per the current magnitude of the modulating signal, and you can see it acquires the corresponding height. And this will go on for all the rectangular pulses. You can see that we are not just adjusting the height of the rectangular pulse, but we are changing the entire magnitude of the rectangular pulse during the pulse duration also. You can see the new magnitude of rectangular pulse is not constant. It is varying as per the original magnitude of the modulating signal. So you can see after the third, the fourth rectangular pulse will have the negative magnitude as the signal is becoming negative. The fifth rectangular pulse will have increased negative amplitude, and so on. So if you simply look at this dotted curve which is following the new magnitudes of rectangular pulses, this dotted curve basically gives you the same shape as the original signal. So what we will actually transmit is nothing but the rectangular pulses, but when they are present close to each other, their amplitudes will help us to trace the shape of the original signal. This is called natural sampling simply because every rectangular pulse will retain the natural amplitude, the original amplitude of the signal.